Question 3 is the elastic rope. In the second part of her act, Hannah flies through the air and lands on an elastic rope, which is held under tension between two supports as shown in the diagram below. Your basic tight rope, essentially, or not super tight rope. Stretchy rope, slack line, if you're into slacklining, look it up. A. Name the main energy changes that occur as Hannah is falling and as she's coming to a stop. So for falling, she's going from gravitational potential energy, EP grav, to kinetic energy, EK. And when she is stopping, her kinetic energy is, we're assuming it's only on the downward part from when the line starts there, so kinetic energy is being reduced and it is transferred into potential energy again, but this time it's elastic potential energy. Okay, in the stretched spring. B. Hannah doesn't like the rope to be too tight when she lands on it. State the direction of her force on her right. This is going to be a okay, no, we'll follow. State the direction of her force on her from the rope. This is important. Not the force she is applying on the rope, but the force the rope is applying on her, which will have to be upwards, because it's decelerating her in downwards direction or accelerating her in an upwards direction. Excuse the lawnmower if you are getting that in the sound too. Explain, in terms of the force acting on Hannah, why the rope should not be too tight when she lands on it. Well, this is that classic idea of impulse. When you want to change the momentum, you have to apply a force over a particular time period. So we don't want that force to be too high. Or if you're looking at it from a Newton's second law situation, we're talking about the acceleration. We don't want that force again to be too high. The mass is fixed, so we have to try and make sure the acceleration is not too high. So these are all relating. Or if you're looking at acceleration being the change in velocity over the change in time. Essentially what you want to do is modify the time, or in the case of acceleration, yeah, you're modifying the time. So you want to increase the amount of time. So increase the time, which will decrease the instantaneous force, which means it's going to be a much more pleasant experience for Hannah to land on the rope. Her feet won't get hurt by too tight a rope and too much force being applied upwards. And that's the essence of that one.